Hello everyone. Our project topic is fine-grained Twitter sentiment analysis. Me, along with my teammates Duncan and Deepika, are going to present the topic. Twitter is a public platform where users can freely share their views, opinions on a wide range of products and topics. It's basically an opinion goldmine. Twitter sentiment analysis can be a great way to take a pulse of what people think about a topic. Like in case of a company like Apple, when it launches a product iPhone 12, it definitely would like to know the pulse of the people about the product. While we say that human emotions are not binary, they are multidimensional and occur in a wide range of spectrums. While we cannot get into the exact granularity of the emotions, we we can still dare to improve on the binary and ternary emotion scale, and we can improve it to a scale of 5 sentiments: very positive, positive, neutral, and very negative. Passing on to you, Deepika.
Yeah. Our problem statement is marketing teams and business executives need a quick way to get aggregated, fine grained sentiment analysis on what their customers or consumers feel. For this problem statement, our proposal is to take the tweets from the Twitter programmatically and feed those tweets to our model, that is take the pulse. It helps us in generating the report with aggregated fine grained sentiments on each topics. So for the tweets pulled, we will generate a report where we have fraction of emotions on each product or service. Now, Duncan will take the pulse model in detail.
Thank you, Topeka. So now we can explore what is inside this black box called Take the Pulse. So Take the Pulse is an SVM model. And what happens during test time is, as you saw in the previous slide, we had all the tweets coming in through Twitter. And so what happens on the back end is that we have two APIs. We have the REST API and the streaming API. The REST API allows us to grab tweets all at once. So we could grab, say, like 1,000 tweets about a certain hashtag. Whereas the streaming API, we sort of connect to a socket on the Twitter end, and we get tweets as they're coming in live. And so for both of this, we'd get the tweets and then we'd pass them through a multi-label classifier that's built on SVMs. For the REST API, would have about 2,000 tweets, and so after we pass it through the classifier, we get some sentiments out of that classifier along the 5 classes that we just talked about, and we plot this on a graph through visualization tools. On the other hand, for the streaming API, we just pass the sentiment of the individual tweets that we received during the streaming process. And so now we'll take a deeper look at the multi-class or multi-label SVM that I just talked about before. How did we get it, and what kind of process do we use to train it? So it starts with Rotten Tomatoes movie review data set. So Rotten Tomatoes has a movie review data set where we have phrases and sentiment values in the range of 0 to 1, going from 0, where it's negative, and to 1, which is very positive. And so we have these phrases which we pre-process, taking care of things like unnecessary white space, necessary punctuation, and numbers and things like that, just getting those out of the way. And then once we have the pre-processed text, we run that through a BERT sentence embedding, which encodes each phrase into a vector of shape 768 and 0. So you have 768 rows for each phrase. So once we have that, we just do some dimensionality reduction through PCA. Scikit-learn has a good library for that, and so we get a vector of shape 512, which turns out being not that bad because we keep most of the variance, about 99%. So it's not there's any loss of information. And then after that, we pipe our vectors from all our phrases into a train test split of test size 0.2. So then the training size is 0.8. And then we pass this training data and the test data to two classifiers. So we looked at OVO, which is the 1 versus 1 classifier, And that's essentially a wrapper around the SVMs where for each class, you have a classifier that's individually pitted against classifiers from the other class. So OVO reduces the multi-label classification problem to, so a five multi-label classification problem is reduced to 10 binary classification problems where each class is pitted against the other class. And then OVR is the one versus rest classifier. That one produces 5 classifiers for each class, where we have each class is competing against a combination of all the other classes combined. So it's one versus the rest, as opposed to one versus one. And so we trained both these classifiers, and eventually we got the best model out of this and used that to build our multi-class SVM. The best model turned out to be the OVO classifier, which we implemented and applied into the pipeline that we talked about in the previous slide. And so that's how Tick the Pulse works. And the idea is that through this pipeline, we can get fine-grained sentiment analysis on live tweets. We get to get a range of outputs from very negative to very positive, and quickly gauge what people are feeling about a certain topic or a certain hashtag. And yeah, that's it for our project. Hope you enjoyed the explanation.